Permutations and combinations sometimes frustrate students, not because of the mechanics of the solving process, but because it's not always easy to know which one to use when. This takes practice, and there are some things to look for that I'm going to share with you. But the main thing is keep working at it and think it through. The key is when order matters, we have a permutation. And when order doesn't matter, we have a combination. Now you may be thinking, well, what does that mean when order matters and when order doesn't matter? We'll look at some examples and I'll try to explain the difference between the two. The main thing is practice and experience is what's going to help you decide when to use which one of these operations. First, we're just going to look at the mechanics of the formulas that are involved with these things, and we're going to start with permutations. And our formula is that NPR equals n factorial over n minus r factorial. And one thing to keep in mind, we use it a little loosely, is why I have the quotation marks. If you come across 0 factorial, we're going to treat that as a 1. Now, what are all these n's and r's anyway? Well, n is the total number of items that are involved, and r is the ones that are being used. You'll see what that means more when we get into word problems. For right now, I just want to look at the mechanics of the formula we've been given and how it works. Let's take a look at an example. Let's say that we want to find the permutation of 6 things taken 2 at a time. What that looks like is this: 6p2. That is a permutation of 6 things taken 2 at a time. We can see that 6 is where the n is and 2 is where the r is, so we're just going to plug those into the formula and have 6 factorial over 6 minus 2 factorial, or 6 factorial over 4 factorial. At this point, you have a couple of different ways you can go, and you should do whatever you're comfortable with. One of the ways is just to find out what 6 factorial is. That's 720. Find out what 4 factorial is. That's 24. And then divide the two. And when you divide those two, you find out that the answer is 30. So, permutation of 6 things taken 2 at a time, our answer would be 30. Another approach that I kind of like here that might take a little getting used to, but it's pretty slick, is 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, which I could write this way. 6 times 5 times 4 times 3 times 2 times 1. Take a second, make sure that you can see how 6 times 5 times 4 factorial is the same as 6 factorial. Once you're comfortable with that, I've got a 4 factorial in the bottom and a 4 factorial in the top. I can cancel both of those. They're just 4 times 3 times 2 times 1 on the top, 4 times 3 times 2 times 1 on the bottom. I can cancel those, which leaves me with 6 times 5, which is 30. Nice thing I like about that is I didn't need to use a calculator at all. I could just write it out, cancel some terms, come up with my solution. Again, you should use whichever method you're comfortable with. Just make sure you can finish this problem correctly and get to that 30. Let's look at the formula for combinations. Okay, it's very similar to the last one. We still have n, we still have r. We're still going to treat a 0 factorial as a 1 whenever we see one. We just have a little extra to plug in for. Let's do an example with this one, and let's look at a combination of 6 things taken 4 at a time. So I'll have 6 factorial in the top. On the bottom, I'll have 4 factorial multiplied by 6 minus 4 factorial. And we're going to go ahead and clean that bottom up a little bit so that we have 6 factorial over 4 factorial times 2 factorial. Now, one thing you definitely do not want to do is multiply those two together and get 8 factorial. Remember, the one on the left there is 4 times 3 times 2 times 1. The one on the right is 2 times 1. There's no 8, there's no 7 anywhere involved. So do not multiply those two together and make it 8 factorial. We're going to simplify right from here. And again, you can go two different ways. You can find out what 6 factorial is. That's 720. In the bottom, 4 factorial is 24. 2 factorial is 2. So we have 720 divided by 48, which is 15. The other approach is to say, well, this is, oh, I want to use a different color. Hang on a second. Which is 6 times 5 times 4 factorial. On the bottom, I've got 4 factorial, and I'm going to go ahead and write that 2 factorial out as 2 times 1. I can cancel the 4 factorials, and so now on the top I can see that I've got 30, on the bottom I've got 2, and so I end up with 15. Either way, I arrive at that same answer. You should do the one that's comfortable for you. Now let's look at these in the context of word problems. A class consists of 7 students. 4 of these students are to be arranged in a straight line for a photo. How many different ways can this be done? The first thing we have to decide here is whether or not order matters. Do we have a permutation or do we have a combination? So the first question is, does order matter? There are a couple ways you can do this, and the best in my mind is just sort of reason it out. If I have some very non-creatively named students, and those students that I have, those 7 students, are named A, B, C, D, E, F, and G, and I'm going to take 4 of those and line them up for a photo. Well, if I take a photo that has A next to B, next to C, next to D, that's going to be different than if I shuffle the order around this way. That's a different picture. B is now on the left instead of being one of the 2 students in the middle. So the order definitely matters here. By changing the order, I've changed the photograph. So order matters, so I have a permutation. So when I go to answer this question and try to figure out how many different ways this could be done, I am going to use the formula for a permutation. And in this case, how many students do I have? Well, I have 7. And how many of them are going to be in this photo? 4. So I have 7p4. This is a permutation of 7 things, taken 4 at a time. And now, for the smooth and easy part, we'll plug this into our formula. I've got 7 factorial over 7 minus 4 factorial, or 7 factorial divided by 3 factorial. And again, there are 2 different ways you can go here. You can find out what 7 factorial is. That's 5040. You can find out what 3 factorial is. That's 6. And then divide those to see that there are 840 different ways that we could take this picture. If that seems like a really high number, start listing them out. ABCD, ABDC, ACBD, ACDB. And all of a sudden, boy, there sure are a lot of these. I haven't even gotten towards E, F, and G yet, and there's a whole bunch of different ways. So the 840 number, I think you can convince yourself pretty easily. The other approach for finishing this up is 7, 6, 5, 4, 3 factorial. That'll cancel with the 3 factorial on the bottom. And then 7 times 6 times 5 times 4 also gives you 840. Order mattered because changing the position of the students made the photograph look different. So order mattered. We had a permutation. A class consists of 7 students. 5 of them will be chosen to go on a field trip. How many different groups of 5 can be made? All right. We're trying to decide whether this is a combination or a permutation, and we'll go back to our non-creatively named students, A, B, C, D, E, F, and G. And this time I'm going to pick 5 of them to go on a field trip. Okay, so if I have A, B, C, D, and E going on the field trip, well, that's the exact same group of kids if I have C, D, A, B, and E going on the field trip. You're either going on the trip or you're not. The order that you're chosen in doesn't matter. This group going on the field trip and this group going on the field trip are exactly the same. The order makes no difference. Not the same as taking a photograph. Now you're either going on the trip or you're not. The order in which you're chosen has no bearing whatsoever. So here, the order doesn't matter, and we have a combination. So we're going to use the combination formula to solve this problem. So there's our formula, and in this particular case, we have 7 total students, and we are choosing 5 to go on the field trip. So we'll plug in the appropriate spots and have 7 factorial over 5 factorial, 7 minus 5 factorial. And that'll be 7 factorial over 5 factorial times 2 factorial. Remember, do not multiply those together on the bottom and get 10 factorial. It'll mess up everything. Instead, you've got 2 ways to finish this. You can figure out what 7 factorial is, which is 5040. You can figure out what 5 factorial is, which is 120. And 2 factorial is 2. So finishing this up, I've got 5040 divided by 240, which is 21. So there are 21 different groups of 5 that I could make with these students. The other approach, if you like that, I've got 7 factorial on top that I am going to rewrite as 7 times 6 times 5 factorial. The reason I stop at 5 factorial is that's the biggest one I have on the bottom. And then times 2 times 1. My 5 factorials cancel. This gives me 42 over 2, which again, it better give me the same result. It's 21. There's 21 different groups of 5 that I could make. Here, order doesn't matter, so we used a combination. Let's look at some key words. In general, if you see these words, it's a really good indication of the type of operation you need to do. For a permutation, if we're going to arrange people, like we were going to with the photo of the students, or in the horse racing problem we saw a while back, what order are they going to finish in? It matters if you finish first or second or third. Order matters. If you see those words, it's a pretty good indicator that we have a permutation. And then for combination, like we're going to choose 5 students to go on a field trip. It doesn't matter what order they're in, we're just going to choose them. And then words that are very similar to that are we're going to pick or we're going to select. If you see those words, it's a pretty good indicator that you're going to have a combination. Also, if you don't see any of these words in the problem, try to replace the verb that's in the problem with one of these words. If it makes sense to use arrange in a problem, then you have a permutation. And if it makes sense to use choose in a problem, then you probably have a combination. Practice and experience will make a big difference here. Be patient, and don't just try something at random. Think it through. Think about whether or not order matters, and then make a decision based on the problem situation you've been given. Practice and experience. That's the key.